In Euclidean plane geometry, a rectangle is a quadrilateral with 4 right angles. It can also be defined as an equiangular quadrilateral, since equiangular means that all of its angles are equal. It can also be defined as a parallelogram containing a right angle. A rectangle with 4 sides of equal length is a square. The term oblong is occasionally used to refer to a non-square rectangle. A rectangle with vertices ABCD would be denoted as ABCD. The word rectangle comes from the Latin rectangulus, which is a combination of rectus and angulus. A crossed rectangle is a crossed quadrilateral which consists of 2 opposite sides of a rectangle along with the 2 diagonals. It is a special case of an anti-parallelogram, and its angles are not right angles. Other geometries, such as spherical, elliptic, and hyperbolic, have so-called rectangles with opposite sides equal in length and equal angles that are not right angles. Rectangles are involved in many tiling problems, such as tiling the plane by rectangles or tiling a rectangle by polygons. Classification. Traditional hierarchy. A rectangle is a special case of a parallelogram in which each pair of adjacent sides is perpendicular. A parallelogram is a special case of a trapezium in which both pairs of opposite sides are parallel and equal in length. A trapezium is a convex quadrilateral which has at least one pair of parallel opposite sides. A convex quadrilateral is simple. The boundary does not cross itself. Star-shaped. The whole interior is visible from a single point without crossing any edge. Alternative hierarchy. De Villiers defines a rectangle more generally as any quadrilateral with axes of symmetry through each pair of opposite sides. This definition includes both right-angled rectangles and crossed rectangles. Each has an axis of symmetry parallel to and equidistant from a pair of opposite sides, and another which is the perpendicular bisector of those sides, but, in the case of the crossed rectangle, the first axis is not an axis of symmetry for either side that it bisects. Quadrilaterals with 2 axes of symmetry, each through pair of opposite sides, belong to the larger class of quadrilaterals with at least one axis of symmetry through pair of opposite sides. These quadrilaterals comprise isosceles trapezia and crossed isosceles trapezia. Properties. Symmetry. A rectangle is cyclic. All corners lie on a single circle. It is equiangular. All its corner angles are equal. It is isogonal, vertex transitive. All corners lie within the same symmetry orbit. It has 2 lines of reflectional symmetry and rotational symmetry of order 2. Rectangle rhombus duality. The dual polygon of a rectangle is a rhombus, as shown in the table below. The figure formed by joining, in order, the midpoints of the sides of a rectangle is a rhombus and vice versa. Miscellaneous. The 2 diagonals are equal in length and bisect each other. Every quadrilateral with both these properties is a rectangle. A rectangle is rectilinear, its sides meet at right angles. A rectangle in the plane can be defined by 5 independent degrees of freedom consisting, for example, of 3 for position, 1 for shape, and 1 for overall size. 2 rectangles, neither of which will fit inside the other, are said to be incomparable. Crossed rectangles. A crossed quadrilateral consists of 2 opposite sides of a non-self-intersecting quadrilateral along with the 2 diagonals. Similarly, a crossed rectangle is a crossed quadrilateral which consists of 2 opposite sides of a rectangle along with the 2 diagonals. It has the same vertex arrangement as the rectangle. It appears as 2 identical triangles with a common vertex, but the geometric parabolic intersection is not considered a vertex. A cross-quadrilateral is sometimes likened to a bow tie butterfly. A three-dimensional rectangular wireframe that is twisted can take the shape of a bow tie. A crossed rectangle is sometimes called an angular 8. The interior of the crossed rectangle can have a polygon density of plus or minus 1 in each triangle, dependent upon the winding orientation as clockwise or counterclockwise. A crossed rectangle is not equiangular. The sum of its interior angles, as with any cross-quadrilateral, is 720 degrees. A rectangle and a crossed rectangle are quadrilaterals with the following properties in common. Opposite sides are equal in length. The two diagonals are equal in length. It has two lines of reflectional symmetry and rotational symmetry of order 2. Other rectangles. In spherical geometry, a spherical rectangle is a figure whose four edges are great circle arcs which meet at equal angles greater than 90 degrees. Opposite arcs are equal in length. The surface of a sphere in Euclidean solid geometry is a non-Euclidean surface in the sense of elliptic geometry. Spherical geometry is the simplest form of elliptic geometry. In elliptic geometry, an elliptic rectangle is a figure in the elliptic plane whose four edges are elliptic arcs which meet at equal angles greater than 90 degrees. Opposite arcs are equal in length. In hyperbolic geometry, a hyperbolic rectangle is a figure in the hyperbolic plane whose four edges are hyperbolic arcs which meet at equal angles less than 90 degrees. Opposite arcs are equal in length. Tessellations. The rectangle is used in many periodic tessellation patterns. In brickwork, for example, these tilings, squared, perfect, and other tiled rectangles. A rectangle tiled by squares, rectangles, or triangles is said to be a squared, rectangled, or triangulated rectangle respectively. The tiled rectangle is perfect if the tiles are similar and finite in number and no two tiles of the same size. If two such tiles of the same size, the tiling is imperfect. In a perfect triangled rectangle, the triangles must be right triangles. A rectangle has commensurable sides if and only if it is tileable by a finite number of unequal squares. The same is true if the tiles are unequal isosceles right triangles. The tilings of rectangles by other tiles which have attracted the most attention of those by congruent non-rectangular polyominoes, allowing all rotations and reflections. There are also tilings by congruent polyabolos.